Welcome to the final exam review. Remember to stop the video before I explain the problems and work them out yourselves. And then listen to me explain them. If you got them wrong, then try them again. Okay, here we go. Okay, find the absolute value. Number one. The absolute value is how far a number is from 0. So negative 24, even though negative 24 is down at the negative end, it's how far it is from 0. So negative 24 is 24. We always talk in terms of absolute values, like when we're talking about debt. We don't say we have a negative $1,000. We say we owe $1,000. We don't say I'm at a negative 10 feet in the water. We say I'm down 10 feet or below 10 feet below sea level. We don't say negative 10 degrees. Usually we say 10 degrees below 0. So those are all absolute values. So an absolute value is always a positive number. Always a positive number. So the absolute value of a positive 24 would be 24. Absolute value of a negative 1 would equal 1. Absolute value of a negative 35 will equal 35. Absolute value of 12 equals 12. Number 2, simplify. Simplify means just what it says, simplify, which means solve the problem in a way. Because solving a problem usually puts it in its simplest terms. Alright, we have to remember our PEMDAS here. Our order of operations. PEMDAS, first thing is parentheses, which actually stands for all organizing things like parentheses or braces or the fraction bar, anything that captures stuff. The next thing would be exponents. You do the exponents after you take care of what's inside the parentheses. Then you do multiplication or division, whichever comes first. And then you do addition or subtraction, whichever comes first. Now, this problem has a parentheses. But notice, what we're going to do is we're going to follow our PEMDAS even inside the parentheses. So we're going to look at this parentheses and say, well, okay, what comes first inside here? All right, there's no parentheses inside the parentheses, and there are no exponents inside there, so we start with multiplication or division. We have 1 multiply. That's 5 times 2. So we'll do that first and copy everything else down. This is always a good practice. Just keep continually copying everything down. 5 times 2 is 10. So it's 10 plus 30. Then divided by 5. Notice we're not going to do the divide by 5 yet. We're going to still finish what's inside the parentheses. We're now down to an addition. So 10 plus 30 is 40. So we've got 40. We can leave it in the parentheses. It's just a grouping symbol. It helps us organize stuff. Alright, now you have to decide which do we do first. Do we add it to the negative 9 or do we divide it by 5? Of course we divide it by 5 because that comes before addition or subtraction. So the answer to that is 8. Now we'll bring into the situation the negative 9, and negative 9 plus 8 is a negative 1. Number 3, 20 minus, in parentheses, negative 7, the second power. Let me rewrite this. Okay, again, we deal with our order of operations. That, too, only deals with what's inside the parentheses. What's inside the parentheses is its base. Negative 7 is the base. So it's negative 7 to the second power, which means negative 7 times negative 7, which is 49. Now we can deal with the 20. 20 from 20 plus a negative 49, which would be 49 minus 20, is 29. since the 49 has a larger absolute value, we keep the sign of the 49, so it's negative 29. Number 4, simplify the expression. We have a negative 4 times 2r plus 2 in parentheses plus 8 times 7r plus 4 in parentheses. So we have a distribution problem here. Let's do the first one. Let's distribute the negative 4 over the 2r and then negative 4 over the 2. Negative 4 times 2r is a negative 8r. Notice we're multiplying the number times the number. Negative 4 times 2 is a negative 8. Okay, that's plus this one. This is again another distribution. 8 times 7r. 8 times 7 is 56. And 56r. Plus 8 times 4 is 32. Okay, now if we look at each of these as signed numbers, we can move them around. What I mean by that is instead of seeing this as minus 8r minus 8 plus 56r plus 32, we'll see them all as being added together. We'll see them each individually as a negative 8r plus negative 8 plus 56r plus 32. This allows us to use the commutative property, which means anytime something is multiplied together or added together, you can move their position. You can move them around, make them commute. So we're going to do that. I'll have negative 8r, and that's going to be plus 56r, and then that's plus, I'll just put a parentheses just to keep the signs separate, negative 8 plus 32. Okay, now I can add them all together. Negative 8r, or combine them if you want to say it that way. Negative 8r plus 56r is 48r. Negative 8 plus 32 is 24. So our answer is 48r plus 24. Number 5. Translate the phrase to an algebraic expression. The quotient of 10 and 5 times a number. Okay, well, quotient automatically should make you think of a fraction, right? It's going to be a fraction. The quotient, or a division. Fraction bar is a dividing sign. But let's use the fraction bar because we use it a lot in algebra. The quotient of 10 and 5 times a number. Okay, the first one is 10. The second one is 5 times a number. You put the first one first. 10, the quotient of 10 and 5 times a number would be 5x or 5n. There it is. The quotient of 10 and 5 times a number. Write the sentence as an equation. Use x to represent a number, then solve the equation. Okay, this is number 6. If 5 times a number is added to negative 6, the result is equal to 11 times the number. Okay, so we could use this sentence a little hard because it doesn't, overlaps, but 5 times a number, okay, it told us to use x, so 5x is added to negative 6, is added to a negative 6. The result is equal to, that's our equal sign. And then the last part is, so on the other side of the equal sign is going to be the rest of it. 11 times the number. 11x. Notice it's the same number, because 5 times the number is added to negative 6. The result is equal to 11 times the number. So we have 5x minus 6 equals 11x. Okay, now solving equations, we always do the same thing to both sides of the equation. So let's get our variables. First thing we want to do is get our variables on one side and all the constants or numbers on the other side. So let's add a negative 5x, and when you're working problems this way where you add things underneath, or sometimes you subtract things underneath, but I recommend always adding them. Always adding. Get in the habit of adding. You're adding here, we're adding a negative 5 to a positive 5, so that's 0. And then the negative 6 is involved in that. So we'll put that down. And then we have 11x plus a negative 5x, which gives us 6x. Okay, so we can not worry about the 0, so I'm just going to erase it. And so we have negative 6 equals 6x. Of course, we want to get the x all alone, so we're going to divide by 6. That'll allow us to have just x. Dividing by 6, those 6's cancel out. This 6 into negative 6 is a negative 1. X equals a negative 1. And notice it doesn't matter which side of the equal sign this is. We could also change it around and say, alright, x equals negative 1. Number 7, solve the equation. If the equation has no solution, write no solution. Okay, so now I have to remember, when we're solving an equation, how do we know if it's going to be no solution? Or the other possibility is infinite solution, or one answer. Well, usually we're going to just get, x equals something, some number, right? But we can, if it ends up being, if it ends up being x equals 5, for instance, okay, that's one solution, and that's what we're usually looking for. The other two possibilities are if we end up having no x's, or the same thing on both sides. Say we have x plus 2 equals x plus 2. As soon as you see is they're exactly the same thing on both sides, even if there's still x's in it, you know that can be infinitely many solutions, because anything we stick in for x in this will work. Or if we subtracted out, or if we added a negative x, to both sides, we'd end up with 2 equals 2. See, so that's a sign that it's infinite solutions to this. The other possibility is if we end up with something like, getting down to the bottom of the equation, we have x plus 5 equals x minus 6, for instance. Or let's say it's x plus 6. Doesn't matter. Okay, if we subtracted out the x's, or if we added negative x to both sides, we'd have 5 equals 6. But we know that that's not true. That's a no solution situation. Okay, so this one is no solution. This one in the red. This one here is infinite. Anything works. And this one is the one we usually have. It's one solution. Alright, we're going to solve the equation. Now, we'll look at both sides of the equation. Look at this side, look at this side. Is there anything that we can combine now? Anything we can simplify now? Well, no, there isn't. So now we're going down to the point where we're going to get all our x's on one side and all our constants on the other. So you can start with either. You can start with the numbers, the constants, or you can start with the x's. I would start with the x's because you kind of decide first then what side you want your x on. So I'm going for the right side because everything will remain, the x terms will remain positive. So I'm going to add a 6x to both sides. And that gives me 0 over here plus 9 equals 6x plus 3x, 9x minus 27. Alright, so now I want to get my x term alone, so I'll take care of the constants. I'm going to add 27 to both sides. That gives me 0 over here plus 9x equals 9 plus 27 is 36. Okay, so we don't need to worry about the 0, so I'm just going to erase it for now. I mean, you don't usually erase them, but for clarity's sake, I erased it. Because 0 is adding 0. Okay, so now we're going to divide by 9 to get our x alone. I want a positive x. I want to find out what positive x is. So divide both sides by 9. These cancel out. 9 into 36 is 4. So my answer is x equals 4. And what do we have? Do we have no solution? No, we have a solution. It's not infinite solutions, it's one solution. So we just leave our solution. X equals 4. I'm happy with that. Number 8. Negative 74 equals 6 plus 8x. Again, another equation to solve. And you have to get good at solving these. You've got to do a lot of them until you're comfortable, keep getting the right answer, so you know what you're doing, because algebra is all about solving equations, so we're not going to get away from it. Alright, so looking to see if there's anything to simplify on both sides first. There's not. So now I want to get my x term alone, so that means adding a negative 6 to both sides. That gives me 0 over here, so I'm just going to write 8x. On the other side we get a negative 80. Get the x alone, positive x alone, we divide by 8, and those cancel. Our x equals a negative 80 divided by 8 is a negative 10. And of course we can check our answer by sticking that negative 10 back in. Anytime you have an opportunity, check your answers. The problem is not too complicated. You know, you don't get a crazy fraction for your answer. Stick the answer back in. See if it's true. If it's not true, oops, a negative 10. There's something wrong with that. Okay, so now, negative 74, does it equal 8 times a negative 10? That's a negative 80, plus 6. Yep, it's because 6 from 80 is a negative, from negative 80 is a negative 74. 74. Okay, 6 plus a negative 80 is negative 74. Notice that this, I know that one side equals another, but this is what you want to get when you check, when you insert into your original equation your answer. You want it to end up being this side equals that side. That tells you that you chose the right number. It's different than if you're solving the equation and what you get at the very end is something equaling something. That's a different situation. Number 9. 4 times, in parentheses, 5x plus 4 minus 27 equals 15x minus 1. Okay, so now we do have something we can simplify before we even get started. So this side has a distribution we can do. And then we'll have to do some kind of addition. So we're going to distribute the 4 over those two things, the 5x and the positive 4. So we get 20x plus 16, and that's minus 27, which equals 15x minus 1. Okay, so we still have more simplification to do. So we can combine the 16 plus the negative 27. That gives us a negative 11, and our 20x. And that equals 5x minus 1. Okay, choose the left side for my x's this time. So I'm going to add a negative 5x. Negative 5x gives me 15x here, minus 11 equals a negative 1, because the negative 5x and the 5x eliminate each other. Okay, now to get my x term alone, I'll add positive 11, both sides. So then the 11's on the left disappear. You have 15x equaling 10. And then I'll divide both sides by 15. And I'm running out of room. Notice I'm not dividing by 15x, I'm dividing by 15. I don't want to just make my x go away, I just want the 15 to go away. So that becomes 15 into 15 is 1, or 1x, or just x. On the other side I have x equals 10/15, and I can reduce that fraction because it's not, that's an answer, that's the correct answer, but it's not in the lowest terms. So I can divide 5 into the top and the bottom. 5 into the numerator into that 10 is 2, 5 into 15 is 3. So my answer is x equals 2/3. Now I don't know if you noticed, but I did something wrong. 2/3 is not the answer. When I thought about it and I looked up and thinking about inserting 2/3 back into my original problem, I realized, wait a minute, that's not the right answer. Something tells me. So I have to go back and figure out what I did wrong. So when I was looking back, I saw, well, there's what I did wrong. I copied this wrong. Sometimes it's just as simple as that. Sometimes you lose a sign, or you multiply wrong, or you add or subtract wrong, and then you get the wrong answer. So this time I just copied the problem wrong. And so we can fix that. We can just redo it. Okay, so let's see if I can fix this. I've put the 1's in where the 15 is, and then this answer is not 15x, it's 5x minus 11 equals -1. I can still add the 11 to both sides, and then I get not 15x, but I get 5x here. 5x. And then instead of dividing by 15, I'm going to divide by 5. Divide by 5, and that goes away, and I'll have x equals 2. And that's the right answer. X equals 2. And we can stick our answer back in just to check. So if this is 4 times 5 times 2 plus 4 minus 27 equals 15 times 2 minus 1. Okay, let me make some room. Okay, so now we'll stick the 2 in where the x was to check. Make sure I did this right, at least the second time, right? So I've got 4 times 5 times 2, that's 10 plus 4 minus 27 equals 15 times 2 is 30 minus 1. Okay, so here we have 4 times 14 minus 27 equals 29. And I need more room. 4 times 14 is 56 minus 27 equals 29. And 56 minus 27 is 29. So 29 equals 29. So 2 was correct after all. Number 10, another equation. Okay, so this one has fractions in it. Easiest way to do problems with fractions is to clear the fractions, clear the denominators first. Then you're just working with integers. Much easier. Okay, you can work it with fractions. That would mean changing both of those fractions into 15ths and then doing something. But I'd prefer to clear them. So let's do that. We have to pick the least common denominator of 5 and 3, which would be 15. Okay, if you don't know which one it is, you go through the times tables. You go through the 5 times table, and you go through the 3 times table, see which one you come to first. So it's 5, 10, 15, 20, 25. And you go through the 3 times table and see which one you come to that's in the 5 times table also. So 3, 6, 9, 12, 15, 18, and 21, 24, 27, 30. Okay, so actually we get up here on top, the next one after 25 would have been 30. Okay, so we have 2 common denominators. We've got 15 and we've got 30. We would eventually get to 30 here in the 3's. but we're talking about the least common denominator because the least common denominator causes the least amount of trouble. So we're going to go with 15. So we'll multiply 15 times both sides of our equation. 15 times this side, 15 times this side. Okay, and now we can take each of these problems and do them separately. Or we could say, all right, so this 15 gets distributed. Let's do it this way. 15 gets distributed over both of those, right? So in a way we could just rewrite it this way. We'll rewrite it 15 times 2x over 5 and then minus, or we could say times, it doesn't matter which, 15, minus or plus, but we could have to, something has to have the negative sign. Okay, 15 times x over 3, and that would equal 4 times 15, which is 60. We can solve that one right now. Okay, so we can do each of these. We'll put 15 over 1, right? And we'll multiply our fractions. Cross cancel here, that becomes 3. 5 into 15 is 3. 3 times 2 is 6. So we have 6x. Okay, here 3 into 15 is 5. 5 times x, 5x, so we have minus 5x. Notice we could have made it a plus and had the x being negative, and it would still come out to the same thing. We would still had a negative 5x, and that equals 60. Alright, so now we just combine 6x and a negative 5x, and we have x. 1x or just x. X equals 60. I'll leave the check to you. Substitute the 60 into the original equation. The original equation was 2x divided by 5 minus x divided by 3 equals 4. Number 11. 4 times 7 minus x divided by 3 equals x. Again, you can think of this as eliminating fractions too. But to do that, we would just multiply both sides by 3. In this case, this is a lot easier. I'll rewrite this one. You have more room. 3 times 4, 7 minus x over 3, and that equals x. Okay, so change this to 3 over 1. Our 3's cancel. And we have, oh, what did I forget to do? We have 3 times x on that side. We've got to do 3. If we're going to multiply 3 on one side, we have to multiply by 3 on the other side too. Okay, so we get 4 times 7 minus x equals 3x. Okay, let's do our distribution. 4 times 7 is 28 minus 4x equals 3x. Add 4x to both sides. We get 28 equals 7x. To get our x alone, just x. Whoops, we don't want to divide by x. We want to divide by 7. Divide by 7. That becomes just plain old x. 28 divided by 7 is 4. So x equals 4. Again, stick the 4 in and check. Make sure we did it right. Okay, we're getting a lot of practice with equations, which is a good thing. We really need it. Okay, so we have 4x equals, number 12, 4x equals 5 times x plus 3 minus x. Okay, so we can simplify the right side by doing the distribution. We'll do that. 4x equals 5 times x is 5x, 5 times 3 is 15, minus x. Okay, so we can still simplify the right side. We have two x's, two x terms, so 4x equals 5x minus x is 4x plus 15. Now, I don't know, you may not be seeing it, but I'm seeing something already here. I know that when I add a negative 4x to both sides, I'm going to have 0 equals 15. You know, both sides are imbalanced. They cannot equal each other, so there's going to be no solutions. But we'll go ahead and do it anyway. Add negative 4x to both sides, we get 0 equals 15. And, of course, 0 cannot equal 15. It cannot. does not equal 15. So this one is no solutions. There's no number you can put in for x that will work. Okay, so far so good. Move on to part 2 for number 13.